Hello, everyone. Today, I'm going to present linear equations, how to graph them. Linear equations meaning straight lines, right? But not necessarily because later on in your studies, now you are probably a middle schooler taking that, but when you get advanced courses in math, excuse me, you would learn that you can have a linear equation in 2D. That would be a plane like this paper. Okay. This would be described by linear equations. If you have a shape that looks like a cube, for example, or a prism, like a rectangular prism, that would be also plane figure. Why? Because it doesn't have curvature. So we call it linear, not necessarily straight line. And of course, in 2D, as we were working here with straight lines, they are straight, right? Meaning they don't have any curvature. It's not like a sine curve or anything else. So how do we graph these and how do we find the equation of straight lines if given some information about it? Okay, so when we say linear equations, I can write it in many shapes. For example, I can say y equals, like you most likely learned, mx plus b. Okay. Or I can say, for example, ax plus by equals c. As long as the x and the y have a power of 1, so there is no square, there is no square root, there is no something, sine of x or e to the y or anything like that. And also, we don't have a term that is a product of xy. So I cannot say y equals m, which is a constant, times x times another variable z. That will not be linear. So linear meaning x and y are my two variables. And when they show up without being multiplied by each other. And the power of each is 1. As you learned, we call the m here, if it's presented in this form, we call that the slope. What is the slope? The slope is basically a change of y divided by the change in x, or change of x. Okay? So if x changes by 1 unit, by how much does y change? That is called the slope. The b is where the straight line will cross the y-axis. So it's the y, we call it the y-intercept. Okay? So you can see here, in order to identify a straight line, I need two conditions or two pieces of information. Let's put it this way. Okay? Um, so two pieces of information, meaning you can give me the slope and the y-intercept. These are two things. I'm not saying give me a value of x is one thing and give me a value of y is another. No, you can give me a coordinate of a point xy. That would be one piece of information. If you give me another point, that would be two pieces of information. So as long as you give me two pieces of information that are not the same, separate, of course, different, then I can find the equation of the line. Let's take some easy examples and then show you how we plot those and then how we go further and deeper in finding or graphing a straight line. So we'll start by showing our coordinate system. The x-axis is the horizontal and the y-axis is the vertical, as we know. And then I tell you, can you please graph the line y equals, say, 2x minus 3? There are many ways. Probably you learned in school to do a table and find values of x. Say x is 0, so multiply 0 by 2 minus 3, so y is negative 3. That's one piece of information. If I say x is 1, you get 2 minus 3 is negative 1. So now I have 2 points. I combine them. Another way to do it is to try to understand what is the meaning of a slope. Okay, so first thing you can do very easily is to find the y-intercept. It's negative 3, meaning my straight line, no matter how, if it's going up or down, but definitely it's passing through this point. That's one piece of information. Another piece of information is to look at the slope, right? The slope is 2, meaning every time x increases by 1, y would increase by 2. It's the change of y over change of x. So if x increases by 1, instead x here is 0, right? If it increases by 1 and goes to 1, then the y would go 1 up to negative 2, another 1 to negative 1. Let's say negative 1 is here. That's all what I need. You don't need anything more than that. And you join these 2 points and extend them, and that would be the line y equals 2x minus 3. So that would be the easiest way to plot. Suppose I give it to you in a different format. I say 2x plus 3y equals, let's use an easy number, 6. You'd say, okay, so I can say 3y equals 6 minus 2x and then divide by 3 to find it. No, you don't have to do that. Never. Another way to say it is you transform that by dividing both sides of the equation by the right-hand side. That's a very nice way to do it. So in other way, I'm going to say, let's divide this equation by 6 and this equation by 6 because I wanted the right-hand side to be 1. Now, if you simplify, 2 over 6 is 3, so x over 3 plus 3 over 6 is 2, so y over 2 equals 1. Do you know what is the 3 and the 2 here? This is the x-intercept, and that is the y-intercept. These are two pieces of information. X is 3, here it is. Y is 2, here it is. I join them together, and that's my straight line. I'm done. Very fast, right? So you don't, some students always try to write it in this form. No, you don't have to. There are many forms that you can get. Now let's take it the other way around. So suppose I tell you, find the equation of a line. If I give you the slope and the y-intercept, then it's so easy. All you would substitute the slope here and the y-intercept here. So that's trivial. If I give you the x and the y-intercept, you can write them here and then take a common denominator and then find 2x plus 3y equals 6. So these are trivial. But we can give you, as I said, many things. I can give you a point on the line and a slope. So instead of giving you a slope and a y-intercept, I will give you a slope and any point, not necessarily the not necessarily this point. No, I can give you, I say, for example, it's this point and that point. Can you find the equation of the line? Or if I give you this point and I tell you the slope of the line is 2/3, whatever. How can you find the equation? So let's get it from first principle. Let's understand. I want you always, when you work in algebra, to connect it to something else like graphing, like geometry, so to speak. It's not geometry, but it's graphing, right? So I want to see what it means. Let's first concentrate on the slope. We said the slope is the change of y over the change of x. So what if the y doesn't change? So I have a horizontal line parallel to the x-axis. So x is 1 or x is 5, the y is constant. So y doesn't change, meaning the change of y is 0. 0 over any other number other than 0 is 0, right? So the slope of a horizontal line is 0. Makes sense, right? So if I want to write a line like that passing through this point and parallel to the x, I say y equals 3. I don't need, there is no x, right? Because in fact, it's not going to cross the x-axis or anything. So this line passing through point 0 and 3 is y equals 3. Okay? What about this line? As x increases, y increases, and as x decreases, y decreases. Meaning x and y go together, either both increase or both decrease, and the slope would be in this direction. It can be more, it can be less, but at least it's going up from left to right or down from right to left. That would be a positive slope. If it's going the other direction, meaning when I go positive along the x, I have to go down, meaning negative along the y. Or if I go negative along the x, meaning to the left, I go positive along the y, meaning up. In that case, this line has a negative slope. If you rewrite this equation, notice I have to subtract 2x from both sides. So I'm going to say 3y equals negative 2x plus 6. And then I'm going to divide by 3 both sides. So I get a negative slope. Okay? A negative slope like we expected. What about the line parallel to the y-axis? X doesn't change, so x is 0. But y, it can be 1, it can be 5, it can be negative 3, it can be anything. So the slope of a vertical line is undefined. If I tell you x equals 4, that's a vertical line because it doesn't have a y component, meaning it doesn't intersect the y. So the slope here is undefined. You can say anything and it would be correct. It doesn't make sense. Slope has to be a specific value. So undefined, 0, positive, negative. Okay? Having said that, let's go back now and say, I'm going to give you uh, some information about 2 pieces of information, no more. But not the slope and the y-intercept, and not the x-intercept and the y-intercept, because we said we already covered those, and these are trivial. So let's say I have a line slope equals 3 passes through any point. We can pick any point, negative 4 and 1, for example, whatever. If you don't need to memorize anything, really, all what you have to do is the following. I'm going to say, okay, let's derive it. I want you always to be able to derive an equation and not memorize it. And you would ask me why? I can memorize it, it's easy. Good. If you end up in science or engineering or math, do you know how many laws and equations will you encounter until you finish your college? Thousands. Are you trying to tell me that you will be able to memorize all of these? It's impossible. What if you forget positive, you switch positive with negative, or x with y, or sine with cosine? You're doomed. So it's not about memorization, it's about understanding. So I'm going to draw a line. A slope is 3. I don't care. It's like, uh, okay, I'm safe through. I'm going to pick any line. It's not the correct line. I'm just showing you how I'm going to derive the equation. So I'm going to draw a line and I say, okay, the slope here is 3, meaning every time you move 1 unit to the right, you go 3 up. And one of the points is -4 and 1. In fact, the point is here, but as I said, it doesn't matter. I'm going to say, okay, it's -4 and 1. Notice that this line has infinite number of points. So I'm going to pick a point, any point. I don't care about it, but I'm going to call it xy. Notice, if I don't know a point, if I don't specify a point, I write it as xy. Like these x's and y's, you can pick any value for x and find the corresponding value of y, or pick any value of y and find the corresponding value of x, right? So when I say x and y, I mean any point. But if I use x sub 1, so instead of, I can call this one x sub 1 and y sub 1. Why? Because I know the point. So that's a given point for you. So to generalize, I'm going to refer to the slope as m, this point as xy, and this point is x1 and y1. What is the definition of the slope m? Didn't we say it's the change in y? Change in y, what does that mean? Y minus y1 or y1 minus y? I don't care, but you have to be consistent. If you say y minus y1, then the change in x would be x minus x1. Here it is. That's it. You say, what do you mean that's it? I mean, slope is 3, so I write 3 equals y is a variable, any point on the line, but y1 is 1, so minus 1, over x, which is any point on the line, minus -4. So it's y minus 1 over x plus 4. Don't have to memorize anything. Now I'm going to cross multiply and say 3 times x plus 4 equals y minus 1. I can add 1 to both sides and write it. If you want, I would write y equals, I have 3 times x is 3x, and 3 times 4 is 12 plus 1 is 13. I got the equation of the line without any memorization. Even when you look at your book, most likely it won't be shown to you as that. It would say y minus y1 equals m times x minus x1. Yeah, exactly. That's what we did here. So this is what you will find in your book, and you say, okay, I have to memorize when I have a point and a slope, the equation is y minus. No, you don't have to do that. How long does it take you to say, this is x1, y1, this is xy, the slope is change in y over change in x, y minus y1 over x minus x1. It's over. And then just cross multiply, you get that equation. Let's take another example. I'm going to stop here because I think that will cover everything you need. Let's say find the equation of a line passing through 2 and 0, or let's make it 2 and something, 2 and 8, and -3 and 4. Okay? Any 2 points. I just made up some points. Again, I'm not going to draw the x and y so that you don't tell me, oh, you drew -4 and 1 in the third quadrant and it should be in the second. Okay, so let's generalize first, okay? And then we substitute. See how nice that would be. X, y. I'm going to draw a line, any line. It doesn't have to be positive slope. Let's make it negative slope. It really doesn't matter. And I'm going to say what I know about it are 2 points, x1 and y1 because it's known, and x2 and y2 because it's also known. But then I will have to add one on my choice, and I'm going to call it xy as before. Now I'm going to tell you, make a statement that would be ridiculous. You'd say, this guy is crazy. But that's how we are going to solve. I'm going to say the slope of the line passing through these 2 points, or those 2 points, it's up to you. Let's say but the slope of the line passing through these 2 points is the same as the slope of the line passing through these 2 points. And you say, of course, it's the same line, and the 3 points are in the line. I say, yeah, but just bear with me for a second. What is the slope of the line passing through these points, these 2 points? It's m equals y minus, like we did it here, y minus y1 over x minus x1, correct? Good. And what is the slope that passes through the two known points? Well, it's I'm sorry, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? Both of them have the same slope, so both of them have to be equal. I don't really care. I don't need to do that. I'm saying the slope of this piece is the same as the slope of that piece. Absolutely, it's the same line. Now let's substitute. I can pick this as x1, y1 or that as x1, y1. I don't care. You pick whatever you want. So I'm going to say y minus y1, which is 8, over x minus x1, which is 2, equals y1 minus y2 or y2 minus y1. It doesn't matter. It's the same thing. There is no, because I've seen it a lot. If you write this as y1 minus y2 over x1 minus x2, no. That's not how the book is saying. It's y2 minus y1 over x2 minus x1, not realizing it's the same thing, right? Multiply top and bottom by -1. It becomes y1 minus y2. So don't be rigid. Once you understand what you're doing, then it's no big deal. You can. So I'm going to say 8 minus 4, which is y1 minus y2. I reverse it just because it's higher, bigger. So I wanted to end up with a positive number. So 8 minus 4 over 2 minus -3 equals 4 over 5. Now it looks exactly like that. A slope equals y minus number over x minus a number. Now you cross multiply, so you get 5y minus 40 equals 4x minus 8. If you want to make it in a slope intercept form, you can. If you want to make it in a standard form like this guy, you can. It's up to you. Or not up to you, really. It's up to the question itself. They can tell you, find the equation of a line passing through these 2 points and write it in a slope intercept form, in which case you will add 40 to both sides. And then you divide by 5, so you get y equals 4/5 x plus 32 over 5. And that would be the slope intercept form. Or they want you to write it in this form, the standard form. So you would say, in this case, you would say 4x minus 5y equals -32. Did I do it correctly? 4x minus 5y equals -32. Right? So that would be one form. This would be another. But we've seen here what I want you to start learning to do in all your math subjects is try to limit your memorization, or better even, don't memorize anything. understand how it's derived, and you can do it in no time. We solved like 3 problems here. In fact, with explanation, it took less than half an hour. So if you were doing this, if I give you this information or that information, it shouldn't really take you 1 or 2 minutes. But if you train yourself to do it from first principles, it would be down the road much, much better than memorization. I hope this was helpful. And again, if you have any questions, please leave it in the comment section and I will return back to you as soon as I can. Thank you and have a nice day. Hope to see you soon. Bye.